Hi students, in this video we are going to study about simple microscope in which we are finding the magnification of the microscope if the final image is obtained at infinity. Okay. Now you know, to obtain the image at infinity, the object should be placed at the focus of the lens. This is the lens. This is the optic center. Let the object be placed at the focus of the lens. Let A, B be the object. The rays from the object passes through the lens after refraction, passes to the focus on the other side, and the ray which is passing through the optic center without any deviation, it travels in the same path, and to obtain the image we retrace the ray backward, and we see that the image is obtained at infinity. Now if our eyes is here, then this angle subtended by the image to the eye is taken as beta. This angle is beta. Let h be the height of the object, and the distance between the object and the optic center is the focal length, so f. Now the equation for magnification of a simple microscope when the image is at infinity is given by, it is the ratio of angle subtended by the image at infinity to the angle subtended at the eye by the object at least distance of distinct vision. In the previous case, the image and the object were assumed to be at least distance of distinct vision, but if the image is formed at infinity also, we are assuming that the object is placed at where least distance of distinct vision. So for that we are drawing a separate diagram. AB is the object, this is the eye, this distance is least distance. So the angle subtended by the eye to the object is alpha. So height of the object we taken as h, and d is the distance from the eye to the object. So we are going to find out what is tan alpha and tan beta from the figure. We call it as figure 1, and this is figure 2. Okay, let us see what is tan beta. Using figure 1, from figure 1, from triangle ABO, tan beta is AB, opposite side by adjacent side, and AB is what? AB is the height of the object. AB is the height of the object, and BO is the focal length. So we can write this as h divided by f. This is equation 1. Similarly, from figure 2, from triangle ABO itself, we can find tan alpha, and tan alpha is given as AB by BO. Now what is AB and what is BO? AB is the height of the object itself. but BO is the least distance of distinction D. So, you can write tan alpha is equal to AB by BO, which is equal to H divided by D. Therefore, magnification M, this tan alpha by tan beta can be written as H by F divided by H by D. H and H will get cancelled, we will get it as D divided by F. So, the magnification produced by a simple microscope for the image, when the image is obtained at infinity, is D divided by F. Now, if we compare this with the equation of magnification when image is at infinity, the equation is M is equal to 1 divided by D by F. We can say magnification produces more when the image is at near point, but you know, if the image is at near point or at the least distance of distribution, what happens? Our eyes will be strained. So, it is better to see object which is little more far away. Okay? And this you must have experienced while traveling, because when you are traveling to a mountain region or something, you can see the mountain from far away, but its size seems to be small. But as you are approaching closer to the mountain, what happens? Its size is increasing, or there is mag, isn't it? Which means when we are viewing objects at a further distance, the size will be comparatively small than when viewed from very close to our eye, but more strained to our eyes itself. Okay, thank you.